Greetings. Okay, so some reminders at the top of the page here from algebra or complex number a plus bi, where I is that square root of a -1. Now don't mistake this for the I vector. Just be careful about the distinction there. One of the things you'll do on some of the homework is plot the point. So A represents the x coordinate, B represents the y coordinate, and you plot the point just like any other xy. Some new terminology that you'll see, modulus. It does mean absolute value, and you will see those single vertical bars, but because this is an imaginary complex number as opposed to a real complex number, you need to do the Pythagorean theorem to figure out that modulus answer. And this is just like the hypotenuse, radius, magnitude that we've done throughout this semester. The polar form of the complex number is written with the trig. So r, the radius, and then either the cosine or sine. So as you can see, SOHCAHTOA is exactly what we're doing here. A, r cosine, B, r sine. So let's try a couple of examples here. So this one is in rectangular form, and I'm going to convert it to polar. So we need to figure out the r. And one of the things I suggest when you do these in the calculator, just ignore any of the negative or minuses in different places and just type it in the calculator with the positive number. I have students that will mess up the calculator with the negative and then get the wrong answer. So let's avoid that. All right, and then we want to get the angle. So just like in the vectors, I'm going to do the reference angle. Again, if I use the calculator, ignore the negative signs. Now this is a unit circle thing, so you could go through the process of sine over cosine, large and small for the numbers. We see pi over 3, but we need the actual theta that represents this specific number. So the x value is negative. The y value is positive. That will be quadrant 2. So I take pi and subtract the reference angle, 2 pi over 3. There's my answer in polar form down there. All right, let's go the other direction. Here is a polar complex number that we shall write in rectangular form, and you can see SOHCAHTOA. A, 3 times cosine, 3 pi over 4. B, 3 times sine, 3 pi over 4. Remember to put the I on that second term. Now you notice all of these i's I'm writing in front of part of it. I put it in front of the square root. I put it in front of the sine. This is just to protect my handwriting because it's not going to be the square root of 3i, and it's not going to be sine of 2 pi I divided by 3. So you just want to make sure your handwriting looks good, so just put it in front of like that. All right, the other things that we do with the complex numbers is we're going to multiply and divide, but we're going to do it in polar form. So some students know how to do this in rectangular form, but it is a little bit easier in polar form. Okay, I just checking my sound there for some reason. Okay, so when we multiply, literally what you're doing when you multiply is you just multiply the radius and then you add the angle. So if you write it formally, as I did on this first line here, it looks like that FOIL situation, multiplying two binomials. You do not do that. That's gonna give you a world of hurt and make it really complicated. I just take the 2 and the 4, multiply them. I take the two angles in question, add them together. There is the answer. I'm done. And then we divide. So when you divide, you're going to divide the radius, and then you're going to subtract the angles. So do be careful. There is a specific order. You do the top divided by the bottom. You do the top angle minus the bottom angle. So Z2 divided by Z1 is different than Z1 divided by Z2. So you have to get that subtraction and division correct. And again, you can see if you write it out, anyways, so 4 over 2 is 2, and then 5 pi over 3 minus 7 pi over 4, negative pi over 12. Anytime you have a negative angle, you should think, oh, negative angle identity, what do I do with that negative sign? And as you can see, for cosine, it just goes away. But for sine, that negative angle becomes a negative in front of the sign, like that. So you have to think about that as well. That is the end of polar form or complex numbers.